Yeah, so today we're going to jump right into a number of the parasitic members of Apidae, and we'll start with Triepeolus, and we'll be reflecting on its relationship to Epeolus, which sometimes is confusing.
Mary or Christine, you have your hand up. Would you like to say something? Christine,
Mary Fabrito,
hand up. Question?
Thanks, Tom.
All right, we'll keep going.
Okay, can you see my screen here? Did I share it? I don't know if I did or not. You see a Triepeolus? Okay. All right, let's share this. It's thinking. There we go. Okay, here's a Triepeolus. Mostly these are parasites on Melisodes, but not always. Few will do Svastra, other eucerines, and there's probably other alternative realities for some of these species elsewhere. Mostly a New World thing. Okay, so in general, when you look at this bee and Epeolus, what you'll be seeing is a lot of oppressed hairs. So these white bands of oppressed hairs. This is not maybe the best model. Let's see if I can get the white balance a little better, and maybe some of the focus. Okay, but it's a little bit dirty, as many of our specimens are. And what you have is tiny, tiny, tiny hairs that are lying flat or prone onto the surface, and they form different types of bands. This banding on the scutum, the shape and size of the banding here on T1 and T2 are used a lot in the identification of this group. So let's flip now to the bee genera memorization chart. And what we'll find is that I think this is Triepeolus here, and we're looking at a male. So we'll go down one. You'll find that the problems are Triepeolus versus Epeolus and telling the two apart. So we'll concentrate on that. They're relatively distinctive as a group, as bees. So they both have 3 submarginal cells. In the female, we're looking at the female. Let's go to the male. The female would have no scopal or pollen-carrying hairs. So in the males and the females, the tips of the axillae are projecting away, kind of like Coelioxys does, and that's very distinct. And a place of differentiation between Epeolus and Triepeolus is that in the males, the mandibles in Triepeolus are always simple. In other words, they just have a simple end point. And in Epeolus, there's usually a secondary tooth on there. Now, I think, having not made a complete study of this, I'm not sure that's 100% of the time, but probably if you saw a tooth, it's going to be an Epeolus in a male. And the pygidial plate is a key one. Usually that's what people would use to tell the males apart between Epeolus and Triepeolus. And in Triepeolus, it's very parallel-sided, and there is usually, but not always, a secondary plane, let's call it, or dividing line, often demarcated by a actual raised line on the pygidial plate that further differentiates it. But a lot of times, if the pygidial plate is retracted, even partially, you can't see if that's true. So often you're left with the fact that you're looking at the mandible. You're also looking at the relative parallel-sidedness of the pygidial plate, and after a while you can kind of get a vibe, which is not always 100%. You'll see an Epeolus exception, a vibe of a larger size and a little bit different in terms of its presentation between the two, if you have time and specimens to look at. Okay, so let's look at some of that. Here we have our male, and let's look at the mandible first, and I'm not sure how viewable that is at the moment, but let's see what we can do. There, its tongue is completely everted. Its mandible is not visible in that view. I'm going to flip it, stick it into the clay via its tip, take the magnification back down, and then we're back up. Okay, so you can see the mandible here, and indeed the outline, which I'm sketching here, has no additional tooth on it. Again, I don't want to be absolutist about this. Someone else may know whether that's a always tooth versus not tooth a way to tell the males apart.
What's the species?
This is Rhododontus, a relatively rare species that Gene Scarpula found one out on Poplar Island in Maryland a few years ago. First record for Maryland. This one is from New Hampshire. So now I'm flipping the specimen, and let's take a look at the pygidial plate on this. So the pygidial plate, not so clear to me what the function is pygidial plate wise on a male, but a number of the parasitic members do have this, and but I'm not sure what it's used for. In the females, it's often used to tamp the lining of the nest, for example. Okay, so here, relatively narrow and long. Again, you know, this is one of these things that's very difficult to be absolute about. And in this specimen, I'll try and, if we have time later, pull some more. The line that we've been talking about that divides it is right there. So it's barely visible because the rim of what should be T6 is partially hiding it. And this separates the plane further down from the plane further back. But again, you know, you could see where I'm going to try and angle it a little bit more, see if we can peek in there. You could see how that isn't a great character because of its ability to hide from you. This is where having a collection of specimens available either in your own possession, which ultimately you would want, or a place nearby that you could travel to with specimens that are question mark, need to be looked at, double checked, verified is good. So it's very difficult to see, but that's the line right there between the two plate faces, relatively narrow. Pygidial plate, but that's a subjective thing. So it's one of these things where we don't have super great characters to tell them apart, although the simple mandible portion is potentially good, but I believe some of the Epeolus species do not have or have that have simple mandibles, whereas most potentially do. After a while, like for example, I never look at the mandible because most of the time you look at it and go, oh, that's an Epeolus. So picture booking on Bug Guide or on iNaturalist, useful to get an idea. Here in both Epeolus and Triepeolus, you have the axillae, which are right next to the metanotum there, axillae here, edge of scutellum there, oh no, sorry, this is, I reverse that. So this is the scutellum, this is the scutum edge border here. You're looking at the pin sticking between the two. And the axillae are always there, but a lot of times they're incredibly inconspicuous because they form a smooth rim with the scutellum. And other than these groups where they project out, they're, as far as I know, I've never seen them used even for species ID. But when you get into species identification, particularly of Epeolus, but a little bit with Triepeolus, the size, shape, and amount of co-joined border with the scutellum becomes important for identification purposes. So there's our Triepeolus male, and now we go to the female. So with the female, we have a different, this is also Rhododontus, get this in focus again. Again, you can see these different patches of oppressed white hairs. Usually the abdomen is very noticeable in terms of its patterns. The scutellum, particularly where the pin is placed in, there's often oppressed white hairs along the rim, and to the interior there's usually a set of 2 on either side in some species. One of the issues often is that fluids from the specimen will leak out of the pinhole and will cover these short oppressed hairs, turning them essentially black. Now, I don't know if that's the case here, but a lot of times any little bit of goopiness will essentially erase from obviousness these oppressed hairs. Usually you get a sense that there is something going on because it's not complete. There's little patches left over, but just be aware that the state of your specimen has an impact on particularly these specimens with low hairs, because almost always when a set of hairs are gooped up, so to speak, they dry and turn dark. So even white hairs will be dark because of the goopiness. Here we have, again, the projecting axilla, and this combination, projecting axilla and these white oppressed hairs, you know you have either Epeolus or Triepeolus with a possible Epeoloides, but we'll show you one of those. It's very unlikely to. So if we go now to the female, look at its characters, you'll see very similar things in terms of telling it apart from other species, like we just mentioned, pressed hairs, axilla pointing out. And then on T5, we'll look at this pseudopygidial patch, as it's often called. The size and shape is going to matter in terms of differentiating it from the Triepeolus. As is a often hidden set of these long parallel-sided, they're just weird things. They're projections. They don't really have their own name. I believe it has to do with forcing nest entry for the females, and they're like a device for sawing into the nest. I'm not 100% sure, but I believe that to be the case. So you can someone can add to that in the chat. But the problem is a lot of times those are retracted and the gate is shut, and you can't see that because the difference between the female Triepeolus and Epeolus is best differentiated if you can see those, because the shapes are different. But we'll go now to the specimens, because the size and shape of the pseudopygidial area is very useful. Again, there is one exception in the East, possibly more elsewhere, but I know this isn't always absolute in terms of telling them apart. So if we go now to the hind end, where all the action is at the genus level and the species level, the action is going to include the shape of these white bands of oppressed hairs, you know, whether this opening is large or small, and so forth. So this is the pseudopygidial area. It's not clearly seen here because of the reflectance, but we are going to zoom in and take a closer look. And at the end of this session, hopefully I'll show you several more of these. And in Triepeolus, the length and the width, this is not a very awesome,
Try the velum thing.
Pardon?
Try the velum thing.
Yeah, let me find my little piece of velum here. And flake this in. So we're getting a lot of reflecting going on, but the pseudopygidial area is defined. You can see the silvery hairs. So there's different sizes and shapes of hairs. So along the rim are usually more white oppressed hairs. This is the patch, the pseudopygidial patch. Let me turn it sideways and see if it shows better on this specimen. If not, I'm going to jump up and get a different one. And in Triepeolus, basically this area from here to here is about as long as it is wide. And in Epeolus, it's shorter. So in other words, the length is about half the width of the pseudopygidial area. Each species has slightly different patterns often in that pseudopygidial area. I have found it to be difficult to describe accurately enough to someone to use well as an ID character, but if you're looking at pictures and you have your specimen, to comparing this region to known specimens, and Molly Reitmeyer has a lovely revision of the genus that should be available online for download. That has lots of pictures for these things, is very useful. Okay, so here's the sting, and these rods are poking out. So unless you pull them, they're almost never completely coming out. These are quite long. They're now in retraction mode. Fortunately, we can see them. A lot of times they're completely invisible because they're in. And what you'll see, I'm going to add some more magnification. That's about all I can get out of it, is these have these little CT sticking out along their edges. This is like a little knife, I would say. It's flattened, knife-like, and quite long. It'll go back to there. So when completely extended, it'll come out to something along those lines. But the end is not expanded, not spoon-like, like you would find in Epeolus. Again, just seeing that makes it Epeolus, but the problem is that a lot of times you don't see that. I'll see if we can get some additional specimens in here in a bit. But let me go now to Epeolus, and let me get my tags on this thing before I forget to do that. Don't want any naked bees running around. Okay, so going to Epeolus. So in general, Epeolus specimens are much less common than Triepeolus specimens. And I am blank. Pardon?
What species are you going to show us?
Epeolus scutularis is the most common in the East specimen or species of Epeolus. And Tom, I think it's Ornifurco, I always mess his name up, did a lovely recent revision of North American Epeolus, which I believe is also available. All right, let's take a look here. They're usually, on average, although there's overlap, smaller also than the Triepeolus, which makes sense because they are, Epeolus are invading the nests usually of Calides, rather than the much larger Melisodes. So let's back off here. But you can see there is a lot of similarity going on with oppressed white hairs, similar kinds of patterns. You have the axillae here that are projecting out. And in Epeolus, the amount and shape and cutoutness and all kinds of things of the axillae become incredibly important. Many species, Scutularis is just one, have extensive reddish, orangish maculations or just parts of the specimen, which also should be a hint that maybe you're looking at an Epeolus rather than a Triepeolus. I don't want to say that Triepeolus never have that, but it certainly is way less common. And off the top of my head, I can't think of any Triepeolus that have reddish integument portions. But if someone can, they should put it in the chat. So we have the same vibe, a lot of the similar layout and patterns in terms of where the white repressed hairs are. And in this one, I'm not sure I have a male or female. Let's see what we got going on at the rear end. We are going to, it's a male, and you can already see that in this specimen, the pseudopygidial area is that going to show? Hopefully it'll lighten up when I bring the specimen up to, yeah, here we go. So the pygidial plate here is much wider in proportion to the previous segment, and it is less parallel-sided, and it is more like a half circle. There is no division of the pygidial plate as there is usually in Triepeolus. But as I mentioned, in Triepeolus, often that division is tucked back in, and you can't see it because this segment is covering it. So more is to look at that and go like, oh, I see, that's quite broad and wide. I have something with a little bit of reddish. I have integument. I have something that's relatively small. I should be thinking at least Epeolus. And hopefully there are other specimens to look at that would help with the confirmation. Now, if we flip this and look at the head, I have not confirmed this for Scutularis, but theoretically there should be a tooth on and so it would have what we would call two teeth. There would be the tip of the mandible, and then there would be a tooth usually set dorsally and set back from the edge. And I believe we do. I believe I'll change the angle. Here's the tip. This is the one that's lapping over the tip, and then there's a tooth right there. Let's confirm that. I have to say, I just don't look at this character that much. A lot of these tend to be in a very general way, but again, not always. More common in the fall in terms of when the populations come out. But that is an overgeneralization. So let me spin this a little bit so we get a different lighting angle and zoom in. So again, I don't want to claim that this tooth business is 100% all the time, but I'm going to say that if there is a tooth, that you can probably take it to the bank, that it's an Epeolus. So hard to see again, I believe that's the tooth there. We'll try and pull out some more specimens in here. I have several in my box, and take a quick look at that. Let's do that now before we get to the female, just to make sure that this tooth business is accurate.
What qualifies as a tooth when it is at the tip?
So it's just nomenclature. So if a mandible has nothing but the blade, the single blade of the mandible, in other words, it's a knife-like, scimitar-like kind of things, the end is considered to be a tooth in terms of counting things, because if it adds another tooth, so this is often on the dorsal side and is something that looks like a bump. It could be mitten-like, a variety of ways, but something that's projecting off of the mandible and is not symmetrical almost always. That would be the second tooth. So they would call it bidentate sometimes in that particular case. But that sort of, so, and yes, in some ways, a single blade of a mandible is not a tooth at all. It is just the end, the point. so to speak, of the mandible. But someone decided that it's also a tooth. Okay, so there's a male, same species, but we just want to look for now the presence of a tooth on a mandible. At least I do, to confirm this toothy thing. All right, let's take it down, bind the thing, come up to high power, bring it down. This is generally a problem with these kinds of specimens where the mandible is not extended out. That's pretty busy in there. I don't see, so there could be a tooth. So here's the mandible in question. I don't see something that I am going to call a tooth in that one. It could be there, but, and this is the problem. This is why when you're holding it in your fingers, and for example, in Nomata, there's a group of species that are bidentate, a tooth on the tip and a tooth on the side, and that is an important character. But a lot of times when you have them, like, is that a tooth down there? I'm not sure. I'm going to get another specimen. You have to rock the specimen carefully back and forth underneath your microscope in order to reveal the tooth. So again, like I'm saying, we're spending extra time here because I have never used this character. I'm trying to make sure that we're looking at a male again. Okay, there's another male. So yet another specimen for which we will try and find its tooth. At some point we will stop doing this, but darn it, I want to see a tooth or not and be clear about it. It's so goopy down there and small. So this may be class homework to see if you can see teeth on these mandibles, because gosh, I just can't. There's so much goop and stuff going on there. So I'm going to assign that to class homework, and I'll take a look too, and we'll come back to witness that. We're just not getting good views enough of the mandible. And because I haven't seen it, I'm, a doubting Thomas to some extent. But now let's go to the female Epeolus scutularis in this case, and we will take a look at the, not the tooth, but we'll look at the rear end of this thing and talk about the pseudopygidial area, which is more visible here, and the odd projections coming out of the either side of the sting. All right, so the key here is that here's the pseudopygidial. It just shows up better. So these are just white oppressed hairs, similar to the ones on other segments. And on Triepeolus too, these would usually be surrounding the pseudopygidial area. And here we see that it's relatively broad, and the length is about half the width of the pseudopygidial area. And these hairs, what makes this different is these hairs are modified and different in presentation. And there's differences among the species, but again, we largely don't use them except to picture book them later as confirmation that we're looking at the same thing, because it's very difficult to describe accurately the differences between the pseudopygidial plates among species. Okay, there's the sting. Here's the tergites and sternite of the last segment. Let's see if we can see. I pulled the specimen on purpose because I believe the spoon-shaped, yeah, So I think the problem, so these are those same segments here that we saw in the Triepeolus. Here's the rim of T, I think that should be T6, and here's the rim of S6. And these are much broader. They're overlapping, so you don't see the rounded nature of them. I'm going to fox it a little bit with the, let me get that out of the way, with the paper to see if that helps. It doesn't seem to. Let me try a different angle. What you're looking for is that the ends of those projections, which call them nest cutters, that they are broadened at the tips instead of just a single parallel-sided, narrow, knife-like thing. And yeah, there. So this is the sting coming up, and these are those internal projecting things, and they are just not super visible from these directions. And they often aren't at all. They're often retracted completely into the interior of the Epeolus. So you can see where these are not the greatest of characters to separate the two groups, and often you have to go and compare them and always be aware that you might think you have an Epeolus, but you actually may have a Triepeolus. And here I will show you the classic case of a irresponsible Epeolus. So this is Epeolus lectoides. I want to say that Epeolus lectoides, what is that? Someone look up, if they would, what it parasites. It parasites something a little bit different, I think, than the normal Calides species. But if we look at it, and this has fooled me a number of times. Oh, I think here we see the sign of the of Epeolus better, but here's a pseudopygidial area. It does look different in some ways from both Triepeolus and Epeolus in terms of the silvery stuff is quite unique to lectoides, I believe. But this distance is about equal to that distance, which is more in the Triepeolus camp. It's a larger and whiter looking specimen with, I think, almost no or perhaps no reddish areas. And these are those spoon-shaped projections that are coming out from the abdomen that are the nest cutters. And I think we can see them a bit better here in this place. So here is the expanded tip. Here's the other one, which is lapped by this one. I'm going to bend this over a little bit more so we can hopefully see it better. And let's go in. See if this helps at all. A little bit. So this is a little bit different view. So here's the tip of the nest cutter coming out, expanding out, not a whole lot, but it's more like a spoon. It's not parallel sided. It doesn't have those big, the CT are not as massive as in Triepeolus either there. And so that would be the sign. But if you look at the overall look of the species, I would look at this, and it's also it's the largest one I know of Epeolus. It looks like Triepeolus in terms of its body size and shape. I can't remember though what its nest parasite of. I want to say Calides latitarsus, but I think that is a different species. I think that's that very colorful Epeolus, but whose name I'm also not remembering. Anyway.
A quick Google Maryland Biodiversity Project brings up parasite of Coides letotarsus.
Oh, it is good. Okay.
That was just like a
Right.
I don't know.
I was thinking of something else then.
A citation for that.
Okay, so now we're going to jump to.
And Jean just dropped in, seconding that.
Okay.
And Coides nudus.
Oh. All right. Anyway, you will be tricked by that group. Here is a species that it would be lovely if you were tricked. This is Epeoloides pilosula, and it is extremely rare right now. It is a nest parasite of Micropus. It's in a different subfamily, Osiris, than the Epeolus Triepeolus group, which I think are Epeolini.
Species name again?
Epeoloides pilosula. And so there have been now some recent records for this species, but they're extremely rare, and there was a hiatus of almost 80 years where no one was finding any, and largely that's because of a combination of what appears to be a loss of Micropus species populations, and also a loss of people looking for Micropus and hanging out and netting bees and nest parasites. So let's go to the guide here, and let's bring this up a little bit. So here is, oh, I don't know if I'm looking at a male or female. It looks like a male to me. Let's see. So if we go to the male, so we see that, we'll take a look. So the axilla are not projecting out, even though it has the vibe of oppressed hairs. They say bands of white hair, oppressed hairs absent or present only on T1 and 2 of the abdomen, although that seems wrong compared to what we're looking at. Length of marginal cell greater than the space from the tip of the marginal cell to the end of the wing. F1, so that's the first flagellar segment, about equal to F2. And then distance between inner borders of eyes much less on the top of the head than below. It says nomata-like. I'd find it more similar to Triepeolus and things like that. Let's look at the eye thing first. So most bees in very general ways have, so this is probably the most distinctive thing about Epeoloides. Most bees either have the eye edges of the compound eyes here and here parallel to one another, or they converge towards the top. Here, or diverge towards the top, converge towards the bottom. In this case, it's the opposite. The eyes are not parallel. They're closer at the top of the head, the vertex, and look at the size of those ocelli. It's interesting. And then at the bottom, they're widely divergent. So that's probably one of the better characters. I have never caught one of these in the wild, so it would be very exciting to see this. So we are looking at something you want to be catching. Here is the antenna. Remember, it said F1 and F2, I believe, were about the same. Is that what it said? Oops.
The question in the chat, are they nocturnal?
I don't know that anyone knows very much about them, but usually when you have ocelli that are greatly enlarged, that is a big indication that they're out either very early in the morning or very late in the evening. Almost no bee is truly nocturnal. Usually they're scavenging light at the beginning and ends of days. I think there might be a tropical exception, and even then it might be that they have to be out during moonlight. If we look at the male thing, so it's saying F1 about equal to F2, and we'll take a look here. So this would be scape pedicel F1, F2. Depending on where you're measuring things, that's roughly true, although F1 seems to be, to me, a bit longer, but they did say approximately. And now if we look at something that I probably would disagree with, is they talked about oppressed hairs on the abdomen being, unless this is a female, I believe it is a male, that they're only, there's either no oppressed hairs, and that looks like, these are more like hair bands than oppressed hairs, but the visual is the same. And maybe they said oppressed hairs. So whether this is oppressed hairs or not, I would say in my book they are. So maybe I don't like this character and we should rewrite it. Bands of white oppressed hairs absent or present only on T1 or T2 of abdomen. I would say that is incorrect. So I have to go back and look at that again. If we go back here and look at the tips of axilla would not be projecting, we'll check that out, and the length of the marginal cell compared to the distance at the end. So if we move this, we should see the area around the scutellum where the axillae are, and very dirty. So here's a Propodium metanotum. I'm going to change the orientation. Scutellum, there's enough hair there that it was hard to see what's going on. One hopes that you would be able to get one of these specimens in a trap, which is where they seem to show up most, is in bull traps these days, which is only a handful. Try and get the light. It's a little difficult to see because there's a fair amount of hair here. Here's the scutellum, but you see no projecting anything out of here. So this is the area the axillae would be, but not projecting. And finally, on the wing, we have the wing here, and the length of the marginal cell here, and here's the tip into focus, that the length of the marginal cell, I'm presuming it's from its basalmost point rather than on the from the tip of the along the margin edge, but that this is longer than this distance from the apex here to the apex there of the wing. True. So I'm not sure which species that separates it out, but in this case, the look of the face is the most reasonable one. Let me see if this next specimen here, I believe it is a female. Epeoloides. Wow, that is a crazy rear end. So I am going to say that is the female. And in this case, it does seem to have more restricted amounts of hair. I feel like we're exploring together on this one. This I pulled from a Smithsonian collection of these specimens. I did not have time before class to look at it. Okay, here's the face. In this case, the female has pretty much parallel-sided eyes. Okay, but fairly large and enlarged ocelli. What do we have here for the female? Axilla not projecting, 3 submarginals, bands of white oppressed hair, absent or present only in T1 and T2. I don't really like that one. Length of marginal cell greater than the space from the tip of the marginal cell to the tip of the wing, and nomata-like. I would suspect that the hind end of the specimen is also illuminating. Go to that. Although I did not see that in any of the guidance on identification. But if we look again here at the where the axilla should be, let's see if we have a better shot of that. Again, lots of hair, very dirty because it's so old. But this would be the area up here. So this is the metanotum. This is the propodium. I see nothing poking out like in others. And the wing cells we saw previously, this is in a very oblique shot of it, but there's the length, and it's greater than the tip to the tip on that one. I'll just look at its back end a little bit more. And it does not have that weird converging and diverging face. But that's a pretty interesting end. And again, because I don't have specimens, these again came from the Smithsonian. I don't know. That's from New Hampshire, it turns out, whether these are indicative or not. Hey, Tim.
Hey, how are you doing?
I'm good. I'm on a Zoom call.
Okay, no problem. I'll talk to you later. Everything's looking good. Keep it up.
All right. All right. So now let's jump to something a little more commonly that shows up, and that would be Holcopasites. So Holcopasites, at least in the East, these are all, and perhaps everywhere, these are Caliopsis nest parasites. And they have a very distinct look, and they're very small because Caliopsis is small. They often don't like to show up in bowl traps, unlike Caliopsis, which shows up all the time, and you have to net them flying over little Caliopsis aggregations. But
what is in
this one, I got my specimens had been given away. This is Holcopasites stevensi. I don't know where that's from. Oh wait, I can tell. This is, but they all look pretty similar. It says Nebraska, so that may be a old name.
it's in Discover Life.
It's in Discover Life? Okay. All right, so this look with the red abdomen with very bright white, but usually dot-like, sometimes striped views is indicative of the species. One tricky part is that the males and females both have 12 antennal segments. So you don't have the usual males have 13, females have 12 sort of thing going on. And so you have to look at the rear end. So if there's a pygidial plate, it's a male, and I presume that it's got the usual 6, or is it 7? I always forget. Segments compared to the female. Let's see what the guide says here. And I believe it is this one. So male only has 12, has only 2 submarginal cells, no scopa on the females, obviously because it's nest parasite, and the base of tergites with broken dense patches of bright white hairs. We saw that. The axilla are not projecting out, and it's small and has no yellow markings, unlike Nomata. And so if we go back and we look at these sorts of things, there's the 2 submarginal cells. Here we can zoom up a little bit more. We'll see we don't have axilla poking out. The presentation is really indicative of Holcopasites. Like when you look at that after looking at a few pictures, you would recognize it right away. The problem would be maybe dismissing this as a wasp in your collection. So here is the scutum up here, and here's the axilla, but it's tucked in with the edge of the scutellum. So, and then the male can be told by that pygidial plate. And if we grab a female here, I believe this is a female, we have the same number of antennal segments as the male, which is 12, but we have a sting in this case poking out, but again, the sting can always be retracted, but we have no pygidial plate back there, and we have the more usual 5, I believe it's 5, 1, 2, yeah, a little bit hard to tell, 3, 4, 5 segments. And species-wise, you can see from the relationship to the pin, it's very small, and you have the red abdomen, and you're going to have the 2 submarginal cells, which you've seen plenty of, so we're not going to look again. And those often have to be caught by slapping on the ground. Now, we're closing in on the end here, so I just want to show you perhaps our most unique, let me pull this out. Epeoloides was pretty unique, but Neolarra, which is a nest parasite of Perdita, is really, first of all, it's incredible.
Before you go too far, can you show the face of the Holcopasites?
Yeah. The face is very, let's say, scrunched up in Holcopasites. It's not very long at all, and perhaps is wider than long.
That's a waspy face.
Pardon?
That is a funky face.
Yeah. And it looks like the antennae are quite low on the face. I think that because it has these other relatively awesome characters, that's not something that comes up in the guides, but there's relatively few, and by low in the face, I mean that if we were to divide the head, and I could make a better portrait of this if I spun this up a little bit to be at right angles to the camera. Maybe we could put that into the guide. That's not actually the best angle either. If we took the plane of the face and put that at right angles to our viewpoint, that's pretty good. And then divided the head capsule, they often call it a head capsule, in half here. We can just use the eyes as a cross. The antennae are below the halfway point. So Duphoria is one of the few that I know of that has antennae below that, and I'm not sure who else might. Maybe Epeoloides too have it below that level. So it has in addition to just overall short head, it has a very short clypeus. And why all that is the case, well, look at all those little bumps. I don't know, but that is also that is part of the vibe. Let me get one more in there. Sticky old trays. I'm looking at Smithsonian collections again. So yeah, here's another one, slightly different angle. And they often have oppressed white hairs on the face. Additionally, and you have those very low hung antennae and short clypeus. And the oppressed white hairs there too. There's the abdomen one more time. And the pygidial plate makes it a male, in addition to the, should be 6, 1, 2, 3, 4, 5, 6 abdomen segments. So Neolarra, nest parasite of Perdita, And in the east, so this is actually a larger one. They are just minute in presentation. And it's probably the smallest bee in North America if people were to measure that out. But it's very uncommon, right? Because first of all, it's small, so it's hard to see and find, and often will get dismissed as not even a bee in collections. And as a nest parasite, it's automatically less common. And as a nest parasite of a relatively uncommon group, in most places, you're just not going to see too many of them except in the deserts of the Southwest. There is a species that's known from the east. Until recently, we hadn't seen it in decades and decades, but I think I heard that someone in the southeast, perhaps Florida, found one recently. So we know that they are still around. But check out this weird venation in the wings here.
You have a Neolarra, what?
It is, yeah, it's upside down. I'll have to get back to you on that, Clare.
Okay.
But it's not the eastern one. But this architecture of the wings, so everything is, all the wing veins are reduced. There's only one submarginal cell, which is, boom, it has to be Neolarra. And the marginal cell itself is just tiny, tiny. So that's pretty much all you have to see right there to tell it's Neolarra. There's really nothing else that will have that combination. And it's so small that it puts it into a very tiny group of possibilities of bees that could be that small. So obviously the females have no scopal hairs, and there, I'm sure, are other features. They often have a lot of little tiny amounts of oppressed hairs, but they don't, and reddish abdomens, but they don't have them. I'll put another specimen under there. They don't have them in the same patterns that, oops, these are old and stuck inside their mocks. I don't want to bust them off. They don't have those patterns like Holcopasites does, but they look dusty a lot of times. So like this one here, because they're covered with a dust of oppressed hairs. But you can see if we back off, so it's on a point, and so it's just super tiny. That might be 2 millimeters in size. But you can see again the reduced veins up here. It may also, well, I don't know. The antennae, now that we're on whether antennae are low or high, that looks about halfway there. But we really just don't need any other characteristics because the wing venation tells the whole story. It is just strange. So that's Neolarra. I think we've gone through everything. So we can see if there's questions or if someone wants me to pull another Epeolus or Triepeolus specimen to look at some of those characters.
Well, it is 2 on the dot,
Oh.
and we have a few things in the chat.
Okay.
Michael says the Oregon Bee Atlas has found Neolarra in 2 locations in Oregon. So yay!
Excellent.
And Will asks, how do you get something so small to pull so nicely for going on a point? That's my kidding nightmare. Are there any tricks to pass on, or was the first one just a lucky pose?
So probably it was a lucky pose. So with a point, usually you're going to have a specimen on your work surface, and then you're going to put a tiny dab of glue. The old timers often would use something that might be fingernail polish, or what else would they use? I think fingernail polish an awful lot. And then you would literally take the point, which is already attached to the pin, and touch it to the specimen. So you would have the specimen on its back or on its side ready to be glued, usually on the back. And you'd come in and touch it, and that's all you would need. They're so light that you don't have to worry about them falling off. I have to tell you that We don't use points because it slows us down. So we would have done the same thing, but glued it to the side of a pin. Additionally, I don't particularly like specimens most of the time on points. The point itself will often occlude some of the parts of the specimen, but then so again does the pin if it's glued to a pin. But additionally, the axis of rotation is now well away from the pin, and when I'm spinning it with my fingers, I often lose it out of the field of view, which has to be at high power because they're tiny. So I still prefer that the specimen be glued right to the pin, which is not as professional for sure as either putting them on a point, or if you really want to be good, you would pin on your main pin a tiny block of foam, cross-linked anthofoam, and then into that foam, so here's the pin, and into that foam you would pin a what's called a minute 10, I think, which is an extremely thin pin, or actually just wire, pointed wire, and then you would put that into the foam, and then you would very gently pierce the side of your specimen, and getting it at the right angle is also a skill set. And you would keep your pins and your specimens that way. Those are the best in terms of picture taking, but I have to tell you, we never go that route because we have so many specimens we're processing. Was there another question?
That is what we have for the day. Okay. So I'm going to stop recording. If you have anything else to put in the chat, we'll be here for another couple minutes.